Alright, silly people, here's the situation. We're going to be doing the integral of this function again, but this time with the adaptive Simpson's rule method, which is very similar to the adaptive trapezoidal rule method, and so should be fairly nice and easy to do. I'm just going to be copying down the equations on the textbook that I have right here. So to start out with, you just start with a value of n that is just 1, so n equals 1. The a is going to be also 0, and the b is going to start at 1. That doesn't really change. But then you go into your loop. I'm going to go ahead and define the error to be quite large, and then the old integral to be nothing at all, so that when we do the loop, we can calculate first values of errors and things. So while the absolute value of e is greater than 1e minus 6, which is our desired minimum error, we do h equals b minus a over n, and then to calculate the integral, there's a couple of different variables that we have to define. So first of all is this s guy here. S is going to be starting out as f of a plus f of b. Yeah, let's just do it like that, f of a plus f of b, with nothing around them. Then you do a for loop for k in range 2 to n minus 2. You want k to be n minus 2. So we set it to n minus 1 for the maximum. But then you only want the even values of k. So if k mod 2 is equal to 0, then it gets the even values of k, and you add on to the s 2 times f of a plus k times h, right? And then after we've calculated s, let's go ahead and divide the whole thing by 3. And I just realized that I should really add plus equals. But then s is that stuff there all divided by 3, so divide equals 3. Right. Then there's also, we have to calculate a value for t. T has a starting value of 0 before the loop. So for k in range, this is where you catch the odd values of k. So we start with n and we go to, or we start with 1 and we go to n, and only catch the odd values to add on to t, and you add on 2 times it's f of a plus k times h again, and you divide it by 3. Once you have both of those, calculating I is you just take your h and you multiply it by s plus 2 times t, and that's going to be the value of the integral. At this point you can get the error, so you can say e equals now, it's going to be I minus your old value of the integral, so I minus I old, and you divide the whole thing by 15, not 3 this time, so that's nice. At this point you can print out your stuff, so you can print first of all your value of the integral, so I equals, I'm going to comma I, and then I'm going to print out the error next, so error equals comma e, and then I'm going to print out the number of slices, so now n equals comma n. And then you make your old integral now equal to your new one. You just multiply n by 2, then you keep going until you get low error values. So let's see how that goes. Okay, so it got the right value of the integral eventually, but with n equal to 256. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it ended up taking more integration steps than the Romberg integration method, but it was still less than the adaptive trapezoidal rule. So I guess Simpson's rule wins again, but not over Romberg. Romberg is still the best we've got so far. All right.